Okay, here's a circuits problem from exam 2 that I'd like to walk you through. In this problem, we have this simple circuit that's got two resistors in parallel, and then you find the equivalent resistance there and put that in series with the 8 ohm resistor. All right, and so you're supposed to determine I, the current I. All right, so I've already given you a hint on how to proceed. You take a look and you're looking to make just a single loop circuit because those are really easy to analyze. And so what I'm noticing here is that these two are in parallel. And so I can take that equivalent resistance. Okay, so that would be 60 in parallel with 120. All right, so that's 60 times 120 over 60 plus 120. Okay, and I think that you plug that in, that simplifies to 40 ohms. Okay, and then this is 8 ohms, and then we still have our voltage source. And so the equivalent circuit here boils down to 48 ohms in a single loop circuit with a 48 volt source. All right, so you apply Ohm's law. All right, so I have this voltage across the resistor is, writing a KCL loop, that would be 48 volts. Okay, and V is equal to I times R. You solve for I, and you get 1 amp. Okay, so that was an easy part of the problem. I now know this is 1 amp right here. Okay, so the next thing I need to know is what is the power used by the 60 ohm resistor? All right, and so here's the idea. You can go back and you can use any equivalent circuit that you need to give you the voltage or the current or whatever through whatever element you'd like to answer the question. All right, so my strategy here is if I know this voltage across the 60 ohm resistor, I could solve the problem. Okay, now it's not 48 volts because there's a drop across this 8 ohm resistor. All right, so I go to this equivalent circuit right here. This is the one I'm going to look at because if I found this voltage, I'll call it V alpha, then I'd be in good shape. All right, and so I know because this is 1 amp, there's a voltage drop across here of 8 volts. Okay, and so writing an equation for V alpha, I have a rise of 48 is equal to a drop of 8 plus a drop of V alpha. All right, so V alpha is equal to 40. Okay, so once I know that, I can get the power of the 60 used by the 60 ohm resistor because I can use the V squared over R formula. Okay, so it'd be 40 squared divided by 60. Okay, and so according to I included MATLAB calculations so you can see the calculations worked out, and you get 26.7 watts coming out of this for part B or part 2.